Hi, welcome to this brand new session of the lab. I hope you had a nice holiday. I know I did. Uh, I wish it would have been on the outside, but well, inside home is nice as well. There's still Netflix, there's still streaming services, and there are still games to be played. So, first of all, please do not forget to go on and show and put your attendance the on the virtual campus. Sorry about the stuttering. I promise I'll try to get better. Now on the virtual campus, we're right here. We're at the subnetting part, and we have a few subjects. We've got the slides that we're going to go over. We have the homework that you're going to do for this lab, and we have the sessions for today and tomorrow. More so, in the attendance sheet, in the static subnetting, you have the 3 sessions for now, for 6 p.m., and for tomorrow at lunchtime. Then, today we're going to discuss a wee bit about computer networks. We're going to discuss a little bit about subnetting. Now, subnetting is the part in which we take one great big network and slice it up into tiny little pieces that are more useful for everyday life. Point worth mentioning, these slides are available for 2 labs, as you can see right there on the right bottom corner. Today we're going to discuss about half of them and half, so we're going to discuss one method of subnetting, and we're going to discuss the other method probably next time. Everyone okay with that? Can you see my screen?
Yes, okay.
Yes.
Okay then. So we're going to talk about why use subnetting. Then we're going to talk today about static subnetting, leaving the dynamic part for next time. We don't want to overburden you for too much, and it's easier that way, and the information gets time to sink in. Now, it's quite important that you remember that whenever we talk about IP addresses and about identities, we have 2 major blocks. We have what is called the public domain and what is called the private domain. Now, on the public domain, those are the ones that are on the left of the slide, and those are granted by the internet service provider, like DG, Vodafone, UPC, Orange, Telecom, so on. And on the right side, we have the private domain. Now, this private domain, you can associate it with whatever happens inside your own home, from the router that brings the fiber optic from the operator, the fiber optic cable, the coaxial cable, or whatever your internet or whatever way the internet comes into your home. And on the right, again, we have the private domain, the private network, in which you can pretty much do whatever you want. Of course, there are some restrictions in that particular part, and those are restrictions that you can probably imagine by yourselves. So again, on the public domain, we have to abide or adhere to certain rules. In the private ones, the network administrator is the one that does whatever they want. And in these 2 labs, we're going to go through one example, and we're going to subnet or distribute or slice up one network according to 2 variants. One is static and the other one is dynamic. Now, in both parts, regardless of the type of subnetting that we're going to do, it's quite important that we remember that an IP address, because if we're talking about public and private domains, we're talking about IPs, so that those are logical addresses. Again, they all have 32 bits split up between network and host bits, and that difference is made up by the network mask. We talked about this in the Mac versus IP lab. We didn't stay in too much on it then because, as I stated even then, we're going to have 2 labs, namely these 2, that we're going to do all the math regarding these two particular parts of the IP address. Is my flow okay? Do you understand what I'm saying? Am I going too fast, too slow?
No, I think it's okay.
It's
It's
okay,
okay.
but what was the network mask?
The network mask is, let me share my screen. Let's share the screen. So the network mask is similar to the IP address in the sense that it provides a differentiator between the host. Can you see it here? Something like a subnet mask?
Yes.
Okay, so whenever you have an IP address on your computer, you're going to have a network mask or a subnet mask attached to it. Today, we're going to talk about it a little bit more, and we're going to see what that one actually does. It's okay?
Okay, okay.
Okay. So, in order to define a network, any network whatsoever, we need three elements. Those are the network address, that is the address by which our home network or an enterprise network is addressed from the outside. We have a broadcast address. What does the broadcast address do?
It spreads to all the networks, right?
Not necessarily to all the networks. There's a lot of networks. Some are in Timișoara, some are in Bucharest, some are in Budapest, some are in New York. A broadcast message can't be sent actually everywhere to other networks.
But it is available.
Not necessarily, it gets cut off. Routers tend to cut off broadcast addresses, broadcast messages, sorry. Do you remember what broadcast actually does?
Sending packets to everybody on the network.
Exactly. So it's a singular, not a plural. One network. Not all of them, not
Okay,
networks.
okay.
Okay. So within the network, a broadcast message is sent from one emitter to all the devices within the same network. The broadcast address, which we're going to find out the magic of the math behind it today, makes sure that that message reaches everyone within the network. The last and certainly not least are the host addresses. What's a host? Can you try to give me examples of hosts within a network?
Are they the servers in which the certain application might be in?
Yes, servers for once. And if you've got servers, you probably also have clients. Remember, we never actually used the term host before. We used a few others. We used computers, we used phones, we used tablets, we use smart TVs, smart fridges, smart washing machines, and everything smart light bulbs. That's the new trend nowadays. Does anyone have a smart light bulb? A smart light bulb is a beautiful piece of technology that allows the user to control the light, the hue, the pitch of any light, of you know, of a light bulb. Yeah. It doesn't do lab homework for you, I'm sorry. It would have been nice, but it doesn't do that. And yes, you can control those smart light bulbs with apps. Now, the idea is that all of these devices that we use within the network, be they servers, printers, phones, whatever, they have a generic name of hosts. And all of them, they all need an IP address or a logical address within the home. Now, the last bullet over there, the fourth one, is called a gateway address. This is kind of a particular host address, so it's kind of one of the same ones. You have to subtract one of those. But in general, do you remember what a gateway does?
It's like a key for stopping the data.
Sorry, a bit louder, please.
It's like a key for stopping the data to spread.
Not necessarily to stop the data from spreading. Anyone else? It's not necessarily a bad definition. It's one of the functions that a gateway could do, but it does a little bit more.
Then like a node in the network.
It's not a node, no. Well, it could be. How would you translate gateway? You know, you take the word and you split it up into two parts. There's gate and the way. Can you find a synonym for way?
A path.
Exactly. So we have a path and a gate. What do you think that gate does to the path?
It opens if it's available, and if not, it closes.
Yeah. The gateway is the element that allows data from your local address, from your local network, sorry, that means from your home to your enterprise, to go out to the internet. So if you would want to access a YouTube clip, you would have to go through the gateway as the first stop, the first hop address. That is the gateway, because information, you don't have a YouTube server at home, hopefully. If you do, tell me how you did it. But basically, YouTube is somewhere across the internet, far, far away. And the gateway address is the element that will allow us to communicate to the internet. It will also block elements, if so particularly set, but it's usually the element which allows us to go beyond. Okay. Now, I'm not going to stand too much at this example because I hope you know it by now. It's the it's the passing between decimal and binary figures. Over here you have 8 bits. And we're going to start the examples today, because this was actually supposed to be a seminar, by starting with an IP address. The IP address you see over there, so 192.168.25.172/24. Now, that particular ending, the /24, represents the net mask or the subnet mask. That means that we have 24 bits of the value 1 starting from left to right within the 32 that is consistent of the IP address. So the first 24 bits are 1. That means the last are the ones that are set to 0. returning to these elements, so the network address, the broadcast address, the host addresses, and the gateway addresses. These are the ones that we are going to look for at this particular network. Both the homework that you're going to have to do and in real life examples, you might find yourself having to receive one IP address with a net mask and have to find an IP address within the same network or the network address or so on. For those people who have joined later, please do not forget to write down your names in the chat and put your attendance on the virtual campus. So the first thing that we have to do is virtually transform the information that we already have into binary. So if we have the IP address 192.168.25.172, and you have beneath it the binary transformation of both the IP address and the network mask. So IP address and network mask, you can see over here that /24 represents 24 bits of 1, and in a decimal system, it's this value here. Now, in order to compute the network address, all we have to do, the simplest thing whatsoever, is to do a logical AND operation between the IP address and the net mask. Can anyone remember the truth value of the AND operation for 2 bits?
Yes, it's true only for 1 and 1, and otherwise it's 0, so false.
Bingo! So when we do this particular operation, we'll see that the first 3 octets or the first 3 bytes are the same because we have to do a logical AND with a 1, and the rest is passed on to 0. Please, and this is important for all the rest of the lab, whenever you write down an IP address, a network address, a broadcast address, a gateway address, or whatever kind of logical address you have, at least for this particular set of homeworks, do not forget to put the network mask attached. You can either put it in a / whatever number or in the decimal form. However, you will be penalized if you do not add the subnet mask. So stages 1 and 2, we transform the information into binary, and then we compute the network address by doing a logical AND between the two. The third step is finding the broadcast address. So again, the broadcast address is the broadcast that we use in order to transmit information to everyone, to every host within the same network. In order to do that, we look at this particular transformation, the binary transformation of the network address we have computed above, and we see that the information is split between 2 parts. Now we have network bits and we have host bits. These 2 categories are separated by the network mask. In our case, the network mask was /24. That means we had 24 ones in the network mask. Those symbols of the network address, the first 24 symbols represent the network bits. The last represent the host bits. Now, in order to get the broadcast address, all we have to do is to transform the host bits, namely the last ones, from 0 to 1. And that's a simple process. We copy everything else, and the last we transform from 0 to 1. And this value is the broadcast address. Are things clear-ish up until now?
If we would have for the host bits 0, 1, 0, 0, 0, and so on, we'll still get it. We just flip the zeros into ones.
When you have host bits, they can only be zeros, because in order to get the host bits, you have to do the logical AND with the zeros.
Oh, okay.
and the logical AND can only turn up zeros.
And the broadcast address is the full.
Yeah.
Okay. Okay.
Yeah, the full, in our case, byte. In the cases of the homework or whichever examples you might come across, it might not be that way. So, is it clear up to this point? We're going to have a few more examples down the line. So, I know it's a bit strange right now. So, in order to get the network address, we do a logical AND. Afterwards, we get the broadcast address by taking the host bits and transforming them from 0 to 1. In order to get the host addresses, we have very simple mathematical formulae. These are decimal values, and they basically state that for the first host, we have to take the network address and add a 1. For the second, add a 2, and so on. And if we go back, and if we do backtracking, you're going to see some examples of this in a moment, but this is just a so-called theory behind it. And if you go backtracking, the last host is usually computed in the simplest way by using the broadcast address -1. Now, after you do a few more or a lot more exercises on this particular topic, all of these formulae will seem, how should I put this? Simple, simplistic, and plainly stupid. But until then, please try to remember them as such. Now, these are the host addresses. The gateway address is the simplest thing whatsoever. You have to choose one address from within the host ones. There are no particular rules as to how to choose that host address. There are, on the other hand, some recommendations, some guidelines. And these guidelines say that the gateway address should always be the first or the last host address. Now, depending on the equipment of the producer, depending on the equipment you have, every producer will have recommendations. For Nokia, for instance, the recommendation is to use the first one, the first host address. If I'm not mistaken, whenever we were in Alcatel, we used the last one, but it's always one of the two, or it should be one of the two. Again, all of these things are developed for the private domain. Again, that is your domain. So you, as a network administrator, make the rules. However, if anything should happen, you might want to use these recommendations so that anyone could come and pick up the gateway to say, I don't know, you get the current virus and you have to stay in the hospital for a while. I have an acquaintance that was happy on this particular topic. Okay. Now, the first type of subnetting, so the first type of splitting up a network that we're going to discuss is the one called static subnetting, in which the network mask is constant throughout the entire process, and the number of the hosts resulted will be the same for each network. Again, we're going to go through some slides of examples in a moment, and all of these things will make a lot more sense. But it's important for you to know them beforehand. What we're going to do is imagine that you're not going to pursue your career as an engineer, and you're going to become, I don't know, something more important, such as a manager. More so, you're going to open up your own software development firm. And if you open your own software development firm, you're usually going to have 3 types of personnel as employees. First off is the developers, because, well, it's a software development company, so you'll probably want some developers. After you have the developers and they write some code, you'll probably need some people to test the code that the first ones have written. And the last is the auxiliary personnel. Now, in this particular auxiliary personnel, you usually enter managers, you enter security personnel. I'm not sure if you've been out, but nowadays, whenever you go to a supermarket or such, there's usually one guard that goes in and takes your temperature and goes like, oh, we have to make sure you're not sick. And these persons are important. More so, these persons from time to time have the tendency to get bored. So it's important that they too have access to YouTube and Facebook. They need to have access, or they could have access to YouTube and Facebook, but should definitely not have access to the development part or the testing part, because corporate secrets are still corporate secrets. So for each of these particular three categories, we're going to design three networks. We're going to split up a network into three parts. We're going to start from the network address that we've computed before, and we're going to go at it one at a time. So if we need three particular networks, we're going to need we're going to need 2 bits in order to represent three particular different numbers. Do you agree?
Yes.
Everyone? Sure?
Yes.
Okay, why isn't 1 bit enough?
You only have the value 0 or 1.
Exactly. Now, if we have these 2 bits, we will borrow them from the host part and add them to the network part. So we have the original network bits, and we add 2 more, the red ones over here. That means that the network address for the new network, namely for the development network, is in numbers, in binary, the same one as the original one, with one slight difference. Can you tell me what that difference is?
We'll have 26 now, right? At the
Yeah.
last part.
Exactly. So we'll have 26 bits, instead of the original 24 in the network mask. Well, if that went well, the rest is going to go swimmingly. So next up, now that we have the network address, we have to compute the broadcast address. And that states that in order to compute the broadcast address, we have to take the host bits, namely these 6 ones in the back, not the network ones, the host ones, and transform them from zeros to ones. And that, if you do the math behind it, you'll get this particular number here. Why is it 63 and not 64? On 6 bits, you usually the highest number you can reach is 64, right?
Yes, but this is with 1 rank less, right? So it's actually 63 because it's 32 plus 16 plus 8 plus 4 plus 2 plus 1.
Exactly. So there's the 2 at the power of 0 at the end. So we have 64 numbers, that's true, from 0 to 63. And now the last part, which was the weird formulas over here, might come into fruition now. We're going to the host addresses. And we see here that the first host is the network address plus 1. And we go to the example and we see that. We take the network address and we add a plus 1. The last address is the broadcast address minus 1. The broadcast address minus 1. Can you tell me, please, how many host addresses do I have in this particular interval?
62.
62, exactly. If I were to grant them access to the internet, I would need a gateway address, namely the first or the last address, and then I would be able to employ a total number of 61 developers. However, the gateway address is one of the hosts. So we have a total number of 62 addresses. Now, do the formulas make a bit more sense?
Yes.
Well, then let's go on to the next network. Now, if we took 2 bits, the first order that we'll have to put them in is 0, 0. What's the next one?
0, 1.
0, 1. So we take the test network and we add the 0 and the 1. So the 2 bits we've already used, the 2 bits we've already borrowed, and we do the rest of the math similar. So we've got 0, 1 here and zeros for the rest of the bits for hosts, and we add and we get a 64/26. Then we compute the broadcast address, in which we turn all of these host bits to ones, and we get 0, 1, 1, 1, 1, 1, 1, 1, and that means 127/26 at the end. And the host addresses, which state that we get the network address plus 1 and the broadcast address minus 1. All things clear?
Yes.
Okay, then we move along. The last is the auxiliary personnel, in which if we had 0, 0, 0, 1, the next possible combination is 1 and 0. So the network address is 1 and 0, and the rest are zeros for the network. And that means 192.168.25 and 128/26. The broadcast address, in which we take all of the host bits and transform them into ones, and then we compute the decimal value again, and we get a 191 at the end. And the host addresses, the host address interval, which is the network address plus 1 and the broadcast address minus 1. Things starting to get clearer? Or still creepy?
Or clear.
Okay. Now, I'm not sure if you've noticed this. We have 2 more minutes left, so unfortunately, after this slide, I'm going to cut out, and please rejoin the meeting. But the network mask for the new networks is /26 for the devs, /26 for the testing environment, and /26 for the auxiliary personnel. That means that each of these networks has the same number of maximum hosts within the network. And this is a representation of the number of hosts per network. Tell me, do you believe that this particular arrangement, namely we have just as many auxiliary personnel as we have developers, is viable for a software development company?
No.
Well, that was abrupt and clear. Thank you. Yeah. So basically, no, it's not going to be much use to us. On what can you think of an example in which a splitting up like this, in which we have a fixed number of maximum hosts, would be useful?
Can you repeat, please?
Can you think or imagine of an example in which a number of maximum hosts would be useful, in which we'd have more networks with the same number of hosts.
In a private environment?
In a private environment, yes, but also in a public one, such as, for instance, the school, in which I know for a fact that within one room I couldn't fit in more than, I don't know, 15 PCs.
I was thinking about a coffee shop as well.
Yeah, coffee shops work as well too. So I'm sorry about this. I'm going to end this meeting and get right back in, okay? Please try to rejoin me, or else the system will cut us off.